You know, O'Neill Sea Odyssey is one of the best programs I've ever been involved in. The ocean is alive, and we've got to take care of it.
Welcome to O'Neill Sea Odyssey. I'm Dan Hafley, Executive Director. We're an ocean-going science and environment program for 4th through 6th grade students. We don't charge money for the program, but we do require each class perform a service project to benefit their community. O'Neill Sea Odyssey's mission is to provide a hands-on educational experience to encourage the protection and preservation of our living sea and communities. What follows here is a condensed version of our field trip on Monterey Bay, and we hope it is helpful to you and that you learn enough to want to protect the ocean that we all share. Now, let's get started.
Hi, I'm Tim O'Neill. I'll be your captain today. Welcome aboard.
I'm Adam Steckley. In today's lesson, we're going to be learning about navigation. In navigation, we'll be teaching you today about GPS, the Global Positioning System, as well as radar, our radio detecting and ranging. And we'll also introduce you to a magnetic handheld compass and learn the process of triangulation.
My name is Yvonne, and my question is, how does radar work?
Radar stands for radio detecting and ranging, and our radar is located partway up the mast. If everybody takes a look up there, that blue disc there is sending a signal out in every direction from our boat. This right here is our radar. Again, the radio detecting and ranging instrument. In the center of the radar is our boat. The line from our boat to the top of the screen shows the direction that we're sailing. So what do you think all this red is here? Land. That's the land, yeah. This is the coastline of Santa Cruz. Here's the tip of the wharf sticking out off the land, and we can change the range at what we're looking at. So we see more land here. Our captain doesn't rely on the radar so much today because even though it's cloudy, those clouds are high over the water, he still has good visibility of where the other boats are out here with us. Our radar echolocates. Have you heard of that before? No. Can everybody say echolocation? Echolocation. What's the other instrument that shows us what's underneath the water? What's the opposite of radar? Starts with an S.
Sonar.
Sonar. Do you know 2 marine mammals that echolocate underwater to find their food or predators?
Whale.
Whales and?
Fish and dolphins.
Dolphins. Whales and dolphins. Very good. Are echolocating. So our radar is echolocating, sending a signal out, a radio wave in every direction from our boat. And just like an echo, when that radio wave hits an object above the surface of the water, it bounces off, returns to our boat, and on our radar screen, we're able to identify anything that's above the surface of the water around our boat, even if we can't see it. Like if we're sailing in foggy conditions or in rain and stormy weather, also at nighttime. Our radar is going to show us what's around our boat so we can navigate safely.
My name is Daisy, and how do compass bearings help you find your way?
If you look down on the top of your compass, you'll see it's in the shape of a circle. So there's 360 degrees there. Does everybody see the letter N? Yeah. What does N stand for?
North.
Right, north.
South, east, west.
All right, north is the starting point of the circle at 0 degrees. Each line on the compass is worth 5 degrees. So from N, you can count to the left 5, 10, 15, 20, all the way around the circle until you get back to N, which is also the ending point at 360 degrees. So what I'd like you to do now is extend your arm and point your compass directly at me. There you go. And you're going to close one eye, line those 2 points up so they form a perfect W. Once you've done that, that yellow or clear line will then fall on one of the lines of the compass to give you either a letter for a direction or a number for what we call a compass bearing. So you're going to take measurements of the angles from our boat to 3 specific points on the land or out here on the water. These are stationary points and ones that we can find on our map of the ocean, our chart. Using our compass through a process called triangulation, which will allow us to identify the position. Those angles then, as we draw them on our map of the ocean, will intersect, identifying our position, again, just like our GPS shows.
My name is Xavier, and my question is, how does a GPS know where you are?
Our GPS is getting our coordinates of longitude and latitude by communicating with satellites that are orbiting the Earth. And those satellites send that information back to our GPS computer, which is on our boat, and it identifies our position here on the water. On our GPS, our digital map, we can identify the position of our boat. There's a red sailboat here, an icon for our boat. Have you all heard of those words, longitude and latitude? So they're imaginary lines. They cover the Earth, and we see those on globes or on maps. And you know which is which? Which lines are longitude and which are latitude? The lines of longitude run north and south around the Earth. Lines of latitude run east and west.
I'm Vince, and my question is, why does the chart show how deep the water is?
Part of our boat extends beneath the surface of the water, so we want to always make sure that we're in water deep enough for our boat. And so our chart, our map of the ocean, shows us depth, basically in units of fathoms, not feet, but fathoms. So how are we going to navigate through the fog?
By lighthouse.
So using lighthouses, right? But that's more so. Wow.
That's a thrasher shark.
There he is.
Wait, who's eating who?
So the sea lion is actually eating the small shark. He whips it around, and as he does, as he thrashes the shark, the pieces of meat tear off. Wow. Pretty powerful. Wow. Exciting.
My name is Stephanie, and my question is, how does a compass find north?
So the Earth's core is iron, and because of the rotation of the Earth, at the very top and bottom of the world, we have 2 very strong magnetic forces. What's called the magnetic North Pole and the magnetic South Pole. Those magnetic forces are working with your compass to provide you with directions. Obviously, as you hold your arm out, N or north will find that strong force of the magnetic North Pole.
To learn more about our program, please go to o'neillseaodyssey.org. That's o'neillseaodyssey.org. This virtual O'Neill Sea Odyssey field trip is made possible by the Community Foundation for Monterey County, Team O'Neill and O'Neill Yacht Charters, and Joyce Anderson Productions. Thank you.